So I think today is the day to explore the multiplexer. Today I will show you the 4x1 marks, but I want to show you that the in two different way. One is the basic if-else method, and one is the basic boolean expression method. First of all, I will show you the if-else method because that is more makes sense. That if-else is more making sense all the things. So first of all, we have to make the file at first. The file name will be very simple, 4x1 marks, the 4x1 marks, and I will try to save it in the suppose documents folder. Nice, choose it, and then I will next. So I have to create the VHDL module first. The name will be MUX, very simple. Now, the main process. So, what is 4x1 marks? So, 4x1 marks having 4 input lines and 2 select lines and 1 output line. So, 4 input lines. What the input line will be? I0, I0, I1, I2, and I3. These will be the 4 input lines. 2 select line S0, S1, and 1 output line. That will Y. Then finish. So if else, so you have to know the how to write the if else, the basic syntax of the if else statement. That I'll tell you. First of all, the basic syntax of the if else statement is the process. First of all, you initialize a process. So process, and then you have to pass the parameters you use as the input symbols. So I1, comma I2, sorry, I0 at first, then I2, sorry, I1, I2, and I3 as input symbol, and then you have to pass the two select lines S0 and S1 also. Then close the bracket and say yes is, sorry, yes. What will be now? You have to begin the if else. So begin. Now write if. What will be? So if S0 and S1, the two select line bit is 0, 0 means S0 is 0. You are checking is it true or not. Okay. If S0 and and S1 is also 0, also 0, then what you will do? Then right, then what you will do? The total, the output y, your output y will be the first I1, the data line, I1 data line, the value of the I1 data line, I0. Nice, that's it. Now copy this for rest of the 3 lines, where you will create the if else ladder, where you use the else if else if part, and at the end you use else, else. I'll come in a little bit. So if this will happen, if not, then else if, what will go? If s is equal to s0 is equal to 0 but s1 is equal to 1 means 0 1, then the output will be I1. If s is equal to 1 and s1 is equal to 0 means 1 0, what will be I2. If s is equal to, and if the else part, what will be else will be the rest 1 1, both will be 1. So you have to not write that No need to write that. Automatically the else part will be automatically you generate. Then y will be your I3. Now you have to end the if, end if, and end the process also. End the process also. Nice. So see the quickly the if else part, is it okay or not? So then save it and let's try to compile it. And I think there is no problem. Yes, there is no problem. You can see the block diagram also, which will take some time. Okay, this is the block diagram, so doesn't make sense. Just go for the testing. Let's go for testing. Then we will come back and replace the if else part with the basic boolean expression, and then we'll check for also for same test cases. Okay, so the parts will comment. I will just quickly do that. So this line will be commented, this line will be also commented, all the lines are commented, and lastly this. Okay, okay, now you have heard everything. So I will fix the I0 to 1's value. Okay, I will fix the I0 to I1's value for see, just see, and what we'll do, and I will explain. I0 will be, I will just keep it I0, and I1 randomly I will just give random numbers, so that you will 0 1 and 0 1 also. I2 0 0, oh, I3 1 1. One pattern is generated, 1 0 1 0 1, but whatever. Now I'll just create this fixed this value, and based on that I will just change the select line output, select line, and the output will be generated based on the I0, and output will be passed based on the four input lines, four input lines. So first of all, the if A00 is 1, A0 is 0, then what will be the output? And S1 also be 0, then what will be the output? We have to check. Logically, what will be? Logically, it will give 0 because I0 is 0. And then I will just copy paste. There is no way I can rewrite it is more 3 times. Okay, now I just check. First of all, I check for 0, I0 and I0 0. Then I check for 0 1, and then I check for 1 0, and then I check for 1 1. And then I will wait for more 100 nanosecond, and then just come test it. ISIM, go for test for ISIM, check the syntax, is it any problem there? I think no, and then run it, see what is happening, is it correct or not? Okay, nice, let's see. Okay, see carefully. First of all, when it will see here S0 and 0 0 0, it will gives output as a 0. Why it will give output as a 0? Because I0 is 0. Okay, nice, right, this is right. Then the S0 and S1 is 0 1 0 1s, so is it is 0 1, then output will giving 1. Why 1? The I1 is 1. Okay, nice. Then go for third case. 1 0 1 0 means it's 2. 2, it will give 0. Why is 0? I2 is 0. That's why. And for last case 1 1, it will 3 means it will give 1. Why 1? I3 is 1. Nice, it will work properly. So okay, nice. Just cut it down and let's do via the basic uh, Boolean expression. So I will comment this out, comment it out. Okay, nice. Now, so what will be the Boolean expression for a MUX? I think you should know. You all know. Nice. What will? So S0, not of S0, not of S0, not of S0, yes, not of S0, and not of, not of S1, not of S1, and I1, I0, sorry, I0, I, I0. This is the first part. Then plus uh, so 0 0 0 1 when ends s will be knotted and not, and s1 will normal, not complement at all. Okay, plus means or and then I will I should copy this. Okay, so just so s will not s1 will be complemented, but s1 0 1 0 1 s1 will not complemented. Okay, it will just write this, then output will be s1 s1. Okay, I1, sorry. Then I will also not I will or now here the s1 will be is not, this will be complemented, but this not. Sorry. Yes. Now that's fine. Let's look good. Now or the last condition, and it will give I1. It will give the I0 as a output. I2 as a output, and it will I3 as a output when the both are not complemented. Is normal. Is this, and it will also yep. Oh, nice. Let's see it is work or not. First of all, I think you should check for it. If 0 0, it will give 0, 0 1, it will give I1, 1 0, it will give I2. Yes, and for 1 and 1, it will give 1 and 1, it will give I3. Now it's okay, I think. Yes, now check it is, check the syntax. Okay, then you can check the block diagram also, but doesn't make any sense, I think. Okay, just see this, whatever. Now this will be make sense, or you can see, but whatever, go for iSIM. That will be more valuable, I think. Test. The test bench will be same for 0 0 1 0 1, and but now it will checking for the equation base. Okay, now equation base is a Boolean expression. So first of all, it checks exactly samely. Okay, first of all, 0 0, it will give 0 means why 0, I0 is 0, so output will be 0 means I0. Next, 0 1 0 1 0 1 means 1, so I1 will be 1, that's why output gives 1. Okay, that's right. Then I 1 0 1 0 1 0 means 2, 2 means I2 is equal to, so I2 is equal to 0, that's why y is equal to 0. Okay, that makes sense. 1 1 1 1 means 1 1 means 3, I3 is 1, so the output will be 1. So the both the cases, the test case will be matched, and you can see, you can just change these values and check for another test case also. So that will be just video okay. So this is a two process. One is if else and one is the Boolean expressions. You can use any of them. As the MUX is a kind of if else statement, so you can use the if else also, because of it will create more sense than this huge equation. So that's on you. Whatever you use, you can use. So okay.